Welcome to Wild Turkey Science, a podcast made possible by Turkeys for Tomorrow. I'm Dr. Marcus Lashley, Professor of Wildlife Ecology at the University of Florida.
And I'm Dr. Will Gulsby, Professor of Wildlife Ecology and Management at Auburn University. We're both lifelong hunters and devoted scientists who are passionate about hunting, managing, and researching wild turkeys.
In this podcast, we'll explore turkey research, speak to the experts in the field, and address the difficult questions related to wild turkey ecology and management.
Our goal
is to serve as your connection to wild turkey science.
Because I'm trying to do split screen here on my laptop.
You don't want the folks on YouTube to be able to see you?
No, it's fine if they see me. I don't need to see me. I have to stare at that mug multiple times a day in the mirror.
Yeah. I'll tell you what, man. I hadn't looked in the mirror in a minute.
I was going to say something mean, but I won't.
Kind of afraid of what I might see at this point.
It looks like you got a little snoot starting to grow there all the time you've been spending with turkeys.
Gosh, man. I kind of have felt like a turkey, and it's been pretty special. So
we're going to drop another episode on that soon, I know, so I don't want to get too far into it now, but I mean, has that not been some of the most meaningful work you've ever done?
It is. I would say it is. It is the most meaningful, probably, already. Mm-hmm. And we're still in the middle of it. Like, I just think the opportunity to learn from that project is so unlimited.
Yeah.
Especially like the epigenetic stuff that might go on over generations. Yeah. There's been no work like that on turkeys.
All right. I was about to bring up something else about it, but I feel like we're about to go too far down that path.
Yeah, let's not go any farther down that.
We're about to have another episode on that soon. We'll focus on the topic at hand today.
Next week, we will cover that topic in detail while it's fresh on the mind. And I also want to I think we should do multiple episodes so people can comment. If you're tired of hearing about the poult work, I guess if we get a lot of comments, maybe we can go to something else. But I think it's so special, and we have so many different perspectives. Our field coordinator, that's over the research, that's been living the turkey life for months now, Ava, I think we should have her on to talk about from her perspective, because she's been an avian ecologist and worked for the National Aviary, and she has a really unique perspective and was behind a lot of the design and stuff that we're doing there. So I think that would be fun to talk to her as well. So I think we should line up some episodes on it and talk about what we've learned so far.
I almost think we might want to do an episode 2, because we're about to, as of the time we're recording this, in 2 weeks from now, we're going to have both of our oldest daughters together with us at the poult facility. Yeah. And I know Evelyn's already gotten to see it, but my daughter Ellie has not, and she's just beside herself.
I'm so curious. I know that just hearing you talk about several things that are going on at home, I know that she's really vested in this, this turkey thing.
You want me to talk about that?
I think we should, and you can talk as much as you want to about it, because I think people would appreciate it at home. But, with Evelyn, my oldest daughter, she's gotten really vested in the poult project at this point.
Yeah.
And, I'm fortunate enough to be able to, get her involved in it to some degree. Obviously, she can't be, a mother hen or handle the turkeys or any of that kind of stuff, like we can as researchers with all the permitting and stuff we've got and everything. But she is getting to go and see them.
Mm-hmm.
And when I pick her up from school, pretty much every day that I pick her up, we kind of switch between which parent picks her up. But when I pick her up, the first thing that she says when she opens the door is, "Can we go see the turkeys?" She's ready. Like, that's what she wants to do.
So
Yeah.
cool.
And
That is my favorite thing about my job is all the cool stuff, the cool, wildlife and conservation related stuff that I get to expose my kids to.
yeah, just kind of trying to reinforce that conservation ethic, and
Yeah.
I want them to care about it too. I
Yeah.
think it's really good, just from a general standpoint, for folks to care about nature.
Yeah.
So it's nice to get to instill that in your own children, and the unique experience that they're going to get to grow up with.
Yeah.
Uh,
Absolutely.
I think that's pretty cool. But yeah, tell us about some of the stuff going on with you and Ellie.
Yeah. So Ellie has formed a non-sanctioned club in her fourth grade class
Fourth
called
grade class,
the Polts Who Care.
the pulse to care.
The Polts
See,
Who
I
Care.
feel. I mean, just stopping right there, I feel like this could be a big thing. Like we could have have some momentum to develop this kind of club all over the place.
Yeah, I
Yeah.
know it's a good idea, and whether her classmates know anything about wild turkeys or not, or interested in the outdoors and nature or not, she is a hardcore recruiter of anyone that she could possibly get. I feel like from some of the things that she's told me, she's like coercing some of these kids to join the club, saying, basically shaming them by saying, "Well, you don't care about the wild turkey. You don't want to save the wild turkey. Like they need our help more than ever." And she just goes into it and goes off on invasive species and not enough prescribed fire and just repeating all of dad's lines, and um which I think what a treasure to be able to have a kid that is wired to care that much, but then also recognizing that our kids feel that way because they're so immersed in it day in and day out. I mean, and it's not just during turkey season. They're not just seeing us hunt, but
Well, she sees
they're
the passion that you exude for it. And
yeah, and they're hearing our dinner conversations all the time, and I'll be talking at dinner about a new paper that came out or something that we got published, or showing the kids a cool video from one of our Nest
yeah,
cameras or something like that, and they're just immersed in it 24/7. But how special is it that she's translated that interest into actually she's like she feels compelled to take action on her own.
yeah. I mean, I think that's remarkable and special. And I know that you feel fuzzy inside for that. Like
Yeah.
I get it.
Yep.
Same. I have the same kind of feeling when I see Evelyn respond. In similar ways. Like she sees me on YouTube and sees the videos and all the different kinds of media and everything. When she sees me on that, she's like, "Oh my gosh, Daddy, you're famous!"
Yeah.
Like seeing her understanding that what we're doing, we're trying our best to get in front of as many people as possible for a cause. And
Mhm.
they're not just developing a care for the cause, but also an appreciation for what we're doing to try to do it. Now your daughter is taking action on. That's really
And holding me accountable. She's holding dad accountable too, cuz like I was telling you earlier, she's developed this habit recently where every day that I come home from work now, she said, she'll ask me, "What did you do to help the wild turkey today, dad?" And going to a series of faculty meetings is not a satisfactory answer for her. She wants more direct action. And so some days I have to let her down a little bit and say, I just had to teach class and go to some faculty meetings today. But it's made me, it really has, like in a small way, made me pause and think about how to allocate time most effectively, because that's really why we're here, right? To try to
yeah.
do that, keeping me honest.
Yeah. I'm doing the same kind of thing. Like we obviously have dedicated our lives to this. I'd spend my work time and my family time and
Hmm.
my personal time focused on turkeys most of the time.
Yep.
So yeah, I think that's pretty special, man.
Yeah. That's going to be a fun trip because we're not only going to get to do that, but we're going to get to talk about the importance of the Florida Conservation Corridor on that same trip too, and we'll be releasing a podcast episode on that. So it's gonna be great for both of the girls to be immersed in it and get the opportunity to go work with Dad a little bit.
Yeah. I know Evelyn has been an ambassador in different ways, and she's going to love that. So I assume Ellie will too. You know, like we've had a couple of times in the recent past. People have probably seen it online, but we've had some of the Mossy Oak gamekeeper crew down here filming,
Mm-hmm.
and Evelyn has gotten to participate in that some.
Mm-hmm.
Uh, just seeing her interact with everybody, and she's all in.
Yeah.
Go to work with Daddy. That's what we're going to get to do.
I bet they're gonna hype each other up about it even more.
I bet they will. I think they'll really. They haven't met each other for everybody out there, but I do think that they have some similarities. Ellie's slightly older, but I think they will get along well.
Yep. It's gonna be fun either way. All right, so back to the topic at hand. We're talking about burning and nesting again today, right?
Yeah, I think we should.
Pretty low key topic.
Yeah. Well, we're definitely we're catching some heat about it. We still, we had a burning and during nesting episode recent. Let's see, what was it? That was with Chris Moorman like 2 years ago now, I guess.
Recently.
Well, I said recently because recently we've been getting a lot of comments on that again,
Gotcha. Yeah.
and it's pretty
It
much
comes up every year.
yeah, like we get a pulse in comments during April essentially or early May every year.
Mm-hmm.
And I also have seen one of them is the same turkey image. I actually went back to see the same turkey image of a nest that got burned is getting circulated again that was last year. But some of them are new, obviously. But
How many times has that hen's poor nest been burned up according to the internet?
yeah, but I mean, people were mad about that. I know that this episode isn't focused on that particular
Right.
issue,
No, it's
but
not.
burning that would be a direct effect that would people perceive negatively. At least I think the literature is pretty clear that it's probably a little overblown
Mm-hmm.
for how people view that. But I can understand the point of view that why would you burn during nesting if you can accomplish the goals of burning at other times, and I'm in agreement with that.
Right.
If you can get your fire frequency without doing that, then there's not a reason to target that time. It doesn't
Yeah.
cause
Sure.
any ecological benefits that you wouldn't get from another time of
Yeah.
burning,
Agree.
or you can't get from another time of burning.
Agree. But there
So
are a lot of people out there that can't accomplish their acres that they need to without burning during nesting too.
yeah, and there's also, agencies that have different objectives and different
Sure.
limitations and things. And that's where a lot of the negativity is coming from, I think, is because a lot of the public land where people interact with fire are some of those areas where the scale of burning and the timing of burning are less than ideal from a turkey's perspective.
Mm-hmm.
So, with that being said, I know you just had some work on a different aspect of burning
Yeah. Yeah.
that
So
I
the aspect of burning that people always think about, and the one that we just covered, is the direct effects. The direct
yeah,
effects of burning on turkeys.
right. But fire is a really important tool for managing for turkeys, and particularly to stimulate brooding and nesting cover.
Mm-hmm.
And you did some pretty cool work that y'all just recently published on that topic. And then I don't know if you remember, but I have an ongoing project. I'm supposed to, as of the day we're recording, I'm supposed to go out tomorrow to place eggs in that study
Yeah.
to look at a different aspect of fire. But I figured it'd be good for us to focus on that recent work that you published because that's one of our goals here is to connect people with current literature and
Mm-hmm.
we'll y'all had it out like a week or two probably.
Yeah. Yeah. It's not long at all.
Yeah.
Yeah, so this work was done on the Talladega National Forest, and their primary funding agency was USDA Forest Service because they were, and I think this is something that's really important for me to emphasize here, is that they got a lot of complaints from turkey hunters. That's a very popular turkey hunting destination for public land hunters in Alabama. And they were receiving a lot of complaints from turkey hunters who were concerned about the burning practices that they were implementing, both in terms of the time of year that they were burning and the scale that they were burning at. And they put some money into it, right? So they funded me and graduate students to go out there and measure the potential impacts that that was having on the turkey population. So even though, to touch back on something you mentioned a moment ago, their fire program is driven by many other objectives besides maximizing turkey abundance. They still understand the relative importance of turkeys to many of the stakeholders on that land that is ours, right? It's American citizens' land is national forest. That's your national forest is the term I think that they use a lot. So they wanted to invest in better understanding how their burning practices were potentially affecting turkeys, specifically indirectly through altering vegetation structure. So that was really the main focus of the study here.
Yeah, and when you were saying indirectly, I guess, one thing that it's doing is affecting the vegetation structure, but I guess
Yes.
the outcome of altering that structure ultimately would be influencing predation of the
Yes.
next, right?
Yeah, that's the
Is that
thought. That's the hypothesis behind it.
Yeah, so is that with your work, that you just published, was that kind of the impetus that you were expecting fire to affect vegetation, which then affects
Yeah,
the risk of the nest of predation?
that's right. That's exactly right. And so, as evidence or as not as evidence, but consistent with that, the way that we set this experiment up was that we divided stands out into their the time since they had last been burned. So we had categories of 1, 2, 3, 4 years since fire, and then anything basically over 5 years that had been burned within the last 10. I mean, essentially at that point, it effectively really hasn't been burned. But we had to put that 10-year cap on it because we didn't want to include a stand that was like, well, it's been burned once in 20 years, right? So we put that 5 to 10 category as the top end. And so our hypothesis, because, we were, just based on the literature, you see a lot of stuff about, we need relatively dense vegetation at ground level, waist to chest high, somewhere in that range. I went into it thinking that, nest success would be lower in units that were burned the previous year or the current year. And then success would go up a little bit in stands that were burned 2 years ago, but then I actually predicted that it would be highest in stands that were burned about 3 to 4 years prior, just because those stands are so dense and there's so much visual obstruction. Now, keep in mind that we laid out the experimental protocol for this study back in, like, I don't know, it's 2018 or somewhere thereabouts. And since then, I've learned a lot of things that make me feel like would have, I probably now would have formulated that hypothesis a little bit different and would have probably predicted that, maybe around 2 to 3 years instead of 3 to 4 years was going to be the optimal time frame since fire to maximize turkey success based on what we've learned more recently.
Mhm. That makes sense.
So
Yeah, and I
that's how
think
go
also
ahead.
telling, I know we've been talking about this recently because we are catching a lot of heat, we'll call it,
Yeah.
uh, to use a pun, not just about this topic, but also I've recently gotten uh, a few hecklers, I guess we'll call them, about predation, which, by the way, I don't think anybody would dispute that predators eat turkeys and their
Yeah.
net and the
Yeah.
pole. that is not the same thing as having data showing that trapping is the answer to the problem.
Yes, those are two
Those are
different
two different
things.
things, and people don't. There are some people that do not understand that, and they think that they're saying that I think that predators don't eat turkeys,
Right.
which I think is kind of ridiculous to say. But
Yeah.
uh, yeah, and also you and I both have multiple turkey predator focused projects ongoing right now.
Yeah.
This was one that had a predator aspect that you just published. It just
Yeah.
is integrating a habitat management strategy with predation, which is what we should be doing,
Right.
right? And we both have stuff where we're trying to standardize part of that equation so that we can look at the other part better.
Mhm.
And every time we do that, people like heckle us that we're ignoring the other part. It's like, no, you're standardizing that part so that you can get a better understanding of the other side of the coin. So anyway, I didn't mean to get
Yeah.
on the long diatribe, but
No, I think it was important.
yeah. Uh, but so for this study, let's just go back to the study.
Yeah.
We'll end up on a big tangent if we don't. So you're looking at time since fire.
Mhm.
I would assume that the vegetation structure in the understory could vary quite a bit across those. What types of stands were they in? Like
So
forest?
the site overall, I can't remember the exact acreage, and I mean it was over 10,000 acres, big chunk of
Yeah.
land. And across that landscape, it was about 40% oak hickory forest, about 25% loblolly pine, 13% longleaf pine, and 11% mixed pine oak.
And were your so the other thing, and we need to address this directly. All experiments have weaknesses,
Sure.
and one that's picked on for this one, I would assume you probably have already gotten some of this. Is you certainly did through the review process of that.
Yeah.
Is that you were simulating nests,
Yeah. Yeah. We were
which is
doing artificial nest.
that has some flaws. Obviously, it wasn't laid by a real hen, but it also has some strengths.
Yeah. It wasn't laid by a real hen. So, it was the spots where we placed the nest weren't chosen by an actual hen. And she didn't incubate the nest, so her scent wasn't there, and you know,
And she
her
wasn't pinning it
visual, yeah, I mean, she wasn't visually there to cue for a predator to cue in on either. So those are major drawbacks to this approach.
right. But that all of that is always thrown out, and then that's used to undermine or discredit or whatever by some. But they fail to acknowledge the opposite side of that coin, which is that allowed you to have a lot of control
Right.
and experimentally try to understand what what the overall effects are, standardizing the nest part of it. You're able to cue in on, well, what is the contribution that time sense fire has,
Yeah.
without having all those other factors or relying on a bunch of hens to hopefully choose sometimes to be in some of the different treatments, right?
Yeah, and case in point, like from all these papers that follow actual hen nests, we know that there are strong trends in where hens select to nest.
Yeah.
So if 60%, let's just say, of the hens, well, actually, let's use real data. We can go back to Craig Harper's study, right, in Tennessee, where you've got half of the hens nesting on, what was it, or 10-ish percent, 7% of the area.
Yeah.
Well, then that by default lets you know that you're not going to be able to examine how successful nests are in other types of areas because your sample is biased towards that early successional cover.
Right. Which a lot of people would be like, well, there's no reason to measure that. Well, if you want to know how beneficial the good cover that they were choosing is, you have to know how bad the bad cover is,
Exactly.
right? So this,
Exactly.
all experiments have weaknesses and strengths, and I think
That's
that
right.
often ignored that there are some real strengths from simulating nests. You have so much
Right.
control to manipulate variables of interest, and you're not saying this is what an actual hen's nesting success
No,
is going to be
that's
of
the
that.
important part.
you're measuring the relative risk of the nest in those different contexts, and
That's exactly right.
that needs to be acknowledged that there's strengths and weaknesses to all kinds of experimental designs, and this one is a tool that we can use to understand things like this that you have difficulty understanding with real hens in the wild.
That's right. The precise and then also just to build out on that a little bit, the precise rates of predation that we saw are not as important as the trends that we saw.
That's
Right.
right.
What is more interesting
Relative,
is yeah,
yeah, it's relative. That's the
exactly.
important.
Okay.
Okay, we've
We
I
laid
think
some
we-
good groundwork there.
yeah,
So
we've gotten
we'll
you ready now to go.
we'll just jump right into it. So we monitored 230 total artificial nests. They were placed out during nesting season, so April to May, both in 2019 and 2020. And like I mentioned a little bit earlier, we stratified those according to when the areas had last been burned. So we had categories for 1, 2, 3, 4, and then greater than 5 years prior fire exposure. And the overall nest predation rate that we documented across those 2 years was 25%, which right off the bat, this speaks to the difference in artificial nest studies and real nest studies because, in a real nest study, we typically see, anywhere from 60 to 80% or something, somewhere about that range of nests being lost to predation.
Mhm.
So,
Can I ask you some questions about the details on that? Like
yeah,
how long would a nest have to last to not be predated?
in this study, it
Yeah.
was only it was only 2 weeks. So that's part of it is the risk exposure is going to be abbreviated compared to a 28-day normal incubation process.
Yeah, but there's also some important things to note there because another aspect of this stuff that has bothered me with the criticism of this kind of approach is that the hen isn't there.
Hmm.
Well, the hen isn't there for a lot of the time 2 weeks. She comes in
Exactly.
and lays an egg and then leaves.
Exactly.
If she has a clutch of 14, that would be for 14 days that she
Yeah.
did, right? Uh, so you actually are mimicking fairly well the laying process with that time frame and
Yes.
the fact that the eggs don't have a hen there.
Yeah.
You're
Yeah.
missing the selection part, obviously, and the scent and motion and everything that comes with her visiting each day. But she comes in for a fairly short amount of time, at least early in laying, and lays an egg and then gets the heck out of there.
Well, my hypothesis would be in the real world scenario that you just described that the predation rate during the laying period would actually be higher because you do have those scent cues there, right? From the hen coming back and forth to the nest, and she spends a little bit of time around it, as we've discussed before, when they're laying.
Yeah,
The other thing that I think is worth mentioning here too is oftentimes when we do these types of studies, or like also as kind of an analogy, when we collar fawns to study fawn predation on in deer, what is the typical reaction? I'll just ask you, what's the typical reaction or question people ask you about the human scent? Like, what bias do people typically can think of human scent as introducing into that study?
well, there's two things. One, but both of them would have the same, I guess, ultimate outcome. People say, "Well, you're leaving scent, which will attract predators, and it artificially increased your predation rate."
Yeah, that's the
Or
most common criticism I get.
yeah, and then the other one that I have heard multiple times, I'm sure you have, is that you are introducing scent and handling the fawn, which is going to make the mother abandon it.
I've heard that one too. But the other one that I don't know why no one ever says this or picks up on it, but what if the human scent actually drives down the predation rate?
Yeah, yeah. It turns out coyotes don't like the scent of humans.
Absolutely. Like, why does no one ever bring that up?
But well, I think it's because the fawn survival is so pitiful.
Yeah.
The fawn
Probably
survival
so.
is 85%. then
Yeah.
people would probably be on that side of the argument. But the
Yeah.
fact that it's 15% or sometimes it's 15 to 45% roughly,
Yeah.
always less survive than more, or than don't.
Yeah. But I think what's important about this, and kind of one of the points that I wanted to make here, and you can agree or disagree, but I feel like there's some people out there right now that have been fairly dismissive of the role that predators play during the laying phase and how many eggs are lost during that laying phase. And I think this is some pretty strong evidence that there's a significant number of them that are.
I agree with that. Why would there not be any nests lost during laying? Just like think about that. We've got a hen laying eggs. Now she does cover them with leaves generally, but they're just laying in the middle of the woods somewhere, hopefully in good cover, but not always. And I think one problem is, and I have experienced this myself, the technology that we were using to detect nests, it, you would not detect them really early in laying.
Yeah,
So in other words, if a nest was lost at day 3 in the laying process, we wouldn't have known she ever started laying
absolutely.
a lot of the time.
Yeah,
With
and
just general GPS, and we wouldn't even know that she was laying based on a lot of the VHF work. We wouldn't really pick up those nests until incubation or shortly before incubation generally.
so for realness, that's kind of a black hole in our knowledge
Agreed, which I
right
think is
now.
an important point. And I mentioned earlier that I have an ongoing project, and we have YouTube videos that we can link here so people can see how we set it up. I don't know if you did document it like that, but we'll link some videos so you can see how we actually set them up. But I've used Lovett's work to try to simulate what does a hen do during laying, and did have the same time period and everything you're doing, because my intent was to study what happens with the nest during laying.
Hmm. Yeah, and if we're willing to accept that a raccoon or an opossum will come along after a hen has abandoned or a hen has died and left those eggs behind, that they'll come along and scavenge those eggs. What is the difference in that versus them discovering those same eggs during the laying process?
I don't know why they would be really quick to jump on eggs from an abandoned nest and not from the one that's laid. The only difference I can think of that, if the eggs are during incubation, they would spoil really quickly. So the scent from spoiled eggs could be relatively quick. And during laying, they haven't started incubating yet. So the development hasn't started. So the egg is stable for a while.
Hmm.
So, like that, I could see where there could be some differences there. But if a raccoon stumbles across some eggs laying in the woods, it's going to eat them.
Absolutely.
So I can't imagine that doesn't happen some.
Right.
Yeah, I have
Right.
heard arguments that it doesn't, and
Yeah.
yeah, I just, well, the other thing is I know from some of the other work ongoing, and also from ours based on the accelerometry, there are definitely nests being lost during laying.
Hmm. Yeah. Why wouldn't
That's
there be?
happening.
Yeah.
Yeah,
Okay, so back to the numbers.
we're
Our
we're
our
going down all these
uh,
rabbit holes, buddy.
it's good though. It's good. I mean,
Yeah.
put it in the context. Overall nest predation rate was 25%. Contrast that with some other studies. There's been other artificial nest studies that find way higher rates, like 60% in East Texas, 70% in South Georgia. But what I think is really important to explain that before we get into species specific predation rates is that we paired this with scent stations to kind of to provide an index of predator abundance on the site, because we thought that that might be important for comparison. And it turns out it actually was, because our scent station visitation rate by the whole community of turkey nest predators was only 34%. So if we had 100 scent stations, for example, 34 of those got hit by a predator, because we put
Mm.
bait in the center of these little track pads, and then we
What
come
is
back
that,
and
like a food or a
it's just a scent
what kind?
tablet, like a scent wafer that you'd use to attract a predator for trapping.
Oh, okay.
Yeah. So it's standardized, so they all get the same, quantity in the same scent, so that it's standardized across those scent stations. So our visitation rate was only 34% overall. And you compare that to some data out of Tennessee that found that they had a scent station visitation rate of 41% of raccoons only. So ours was 34% when you include fox, coon, possum, everything on down the list. But theirs was higher than that when you just segmented or filtered the data down to raccoons only. So starting out, the predator context on our site may have been reduced compared to some other sites.
Mm-hmm. And
So
that is those in the middle of national forests.
yes.
So one, I don't know anything about the Tennessee study, but they weren't feeding them, at least the predators there.
Yeah, there
So
was no feeding in our
I
study, I
can
know.
I can't imagine in some places that predator index wouldn't be 100%,
Right. I can
especially with
imagine.
raccoons that are the primary visitor to the corn
Mhm.
feeder.
Yeah. Yeah. So this was also kind of interesting because the species specific predation rates weren't where you would typically expect them to be in terms of order of the number of nests depredated. So gray fox was actually number one. So gray foxes took 10 nests. Possums were next with 9. Coyotes was 7. Raccoons 5. Crows 5. Pigs 4. And skunk 1. Um, so that was probably one of the most surprising aspects of the study for me was that gray fox were number 1, and then coyotes were still a little bit higher than even raccoons.
That is interesting. Well, the other thing is so it was fox 1, coyote 2, or what was number 2?
Fox 1, possum 2, coyote 3, coon 4, crow 5.
So 2 of the top 3 will also eat the hen.
That's right. Yeah, gray fox and coyotes will certainly eat the hen.
Yeah, that is interesting. Hmm. Okay.
So
Well,
the other thing that I thought was interesting, kind of a little side note here, and this touches back on something we briefly mentioned a moment ago. There were only 2 instances of secondary predation that we recorded, where one predator came by, but there were still some eggs left, and then another predator came by.
oh yeah, that's
Um,
interesting too.
yeah, and remember that these were only 14-day periods, but so I mean, if it had gone 28, that number would have been a little bit higher. But we were concerned about everything starting to stink if we went much longer than a couple of weeks.
Yeah. No, I think that, I mean, using unwashed chicken eggs or very similar stability to wild turkey's eggs during laying, like we were
Hmm.
just discussing, and you are simulating really well, I think, the laying process
That's
because those
right.
eggs are pretty stable. But as soon as one gets broken, it's not anymore.
That's right.
But it is really interesting to me. So I guess you guys were trying to like keep up with how many eggs are still present and viable,
Yeah.
and
Well,
you
I mean,
didn't.
I don't think I even mentioned this, but we had cameras recording in high definition on each of these nests, so
Yeah,
they were video recordings.
yeah, and we I know you have some really awesome footage, and
Yeah,
we
we'll
could
cut
kind
in
of
some of that footage.
yeah. I know we've used some footage of your
Yeah.
foxes and coyotes before on
Hmm.
different things that we've done, but um, yeah. So basically, I guess if I was just thinking about that, I would have expected it to be the norm. Like if somebody cracks open some eggs and there are some eggs left, like that's gonna be a bunch of rotten eggs
Yeah,
still laying around, and that would have attracted things to come scavenge the other ones.
I would think so too.
Yeah, that's
I
interesting.
would. I think we might want to dig into this a pretty good bit because I think it's going to catch your attention. The average time to nest predation was 6.4 days, and it ranged from day 1 to day 14, which, I mean, the range isn't that surprising. You had instances on day 1 and instances on the last day, but the average time was about 6.5 days. So
Yeah.
that speaks to what you brought up earlier. A lot of it was happening fairly early in the process, which would make it difficult to,
To back in real
yeah,
hands.
to detect that using GPS data.
Yeah. That's really, really interesting. And it's remarkable the similarities between, the stuff we've observed in year one. We're in the middle of year two now. My study is complementary to this. We are looking at the long term effects of fire frequency. So, where you were looking at time sense fire,
Hmm.
that's different than long term changes in vegetation structure,
Yes.
where we isolate the frequency that's
Yes.
affecting the structure at a given time sense
Yeah.
fire.
That's right.
So I don't know if that made sense to people, but ours is we are working. I'm working with Dwayne Elmore at Tall Timbers on a project where we're using the Stoddard plots that have been in given fire return intervals for 60 something years. So, like, if you were going to have if fire frequency is going to have an effect, it has had the effect there,
Yeah.
right? So,
Absolutely.
and I'm really interested in those long term effects of the
Yep.
fire frequency, but uh, it's kind of interesting based on our year one how similar some of these things are to what you're saying.
Hmm.
I'm curious, did you have any corvids?
Yes. Yeah. 5 nests were taken by crows.
Okay, but no blue
Hmm.
jays.
No blue jays.
That was something that surprised me,
But
and
we
I average
but
at
we
least.
did have, like, there were, like, I'm trying to remember the exact number. It was in the teens of instances of predation where, for whatever reason, we didn't capture footage of it.
Okay,
And I would say that that would probably be, typically, like, I could see like a blue jay or something smaller, maybe even a snake, you know,
yeah,
slipping
I was
by and
thinking
taking
about
some
that.
eggs.
If you detected snakes, and then one flaw with the technology we were using is it wouldn't detect small stuff, and particularly snakes. So,
Yeah.
you, I assumed you probably had some eggs stolen that you didn't.
Yes. Yeah. Which is why we've modified that, because we now also have a similar study going on where, kind of like you are, instead of just looking at time since fire, we're doing a variety of different vegetation manipulation strategies and then placing artificial nests in those. So, like, some are burned, some are sprayed and burned, testing different herbicides and things like that. And we've modified the protocol to where now we have these cameras mounted kind of above the nest and looking
Yeah,
down at it so that it's more easily triggered.
yeah, and also one thing that we have, I don't know if you guys do, but we have our camera on a field scan mode, and we've
Hmm.
detected some stuff, particularly blue jays, that didn't trigger the camera. We just happened to catch them because we have it
Hmm.
triggering on its own, frequently.
Yeah,
So
that's
it makes
cool.
it a huge pain to go through the data.
Oh, yeah.
But yeah, I was kind of concerned that we were going to have a bunch of snake and we wouldn't detect any of them. So
Yeah.
that's what we're doing.
We're
And
getting some super cool footage from the stuff that's going on right now, and we'll share it at some point, I'm sure. But as part of that current study, we had a bobcat show up at one of our nests the other day. And in this particular study, we're actually putting hen decoys on our nest. So this is like a new element that no one's ever tried before, to see, like, how much does that visual cue matter. And we're trying to, we're trying to up our level of realism for this study. And bobcat comes along and knocks the hen off the nest, and then, realizes it's a decoy. So the decoy's just kind of laying off to the side now. The bobcat's no longer interested in it. So then the bobcat goes over and eats an egg or two, and then walks back over, still in view of the camera, beside the nest, and curls up like a freaking house cat and takes a nap.
oh man, after it got its egg breakfast.
Yeah. And I mean, I'm talking about, like, it's like stretches its paws and kind of gets all comfortable and
Yeah.
everything.
Well, we need to cut that in.
Yeah.
That's stuff.
All
Yeah.
right. So you want to get to the meat and potatoes of this now because we've been going a
Well,
while.
probably a few people irritated that we haven't
Yeah.
yet. Yes. Like, what was the effect of fire? Time since fire.
There was none. So I guess we have to go back and delete all our previous episodes about how fire helps turkeys, right? No, there was none because canopy cover
Yeah.
averaged 90% across the site.
So essentially, there wasn't enough sunlight for the fire to generate the changes in vegetation that you would.
Yeah.
So, did
So
you
not
guys?
only, let me add to that, this is important. Not only was there not a trend in terms of a fire effect on nest success, but there wasn't even an effect of time since fire on vegetation structure or species composition.
Yeah, which tells you why there wasn't an effect.
Yeah. So burning under a closed canopy, fire in and of itself is not a panacea, right? So if you don't have, we talk about the two key ingredients are sunlight and disturbance, right? So the sunlight just gives you the potential to grow vegetation. And then the fire helps shape what that vegetation consists of. You have to have both ingredients to successfully manage for turkeys. If you open the canopy and you don't burn, you might get a few years of good nesting and brooding cover, but then after that, no more, right? That eventually becomes a hardwood mid-story, and you're back in the same situation where there's very little visual obstruction in the understory. If you just burn and you don't do the work to open up the canopy, essentially you're clearing leaf litter, which it may have some attraction to adult turkeys, right? To facilitate their foraging for insects. Um, but you're not going to elicit a significant change in the vegetation in the understory by doing that.
Yeah. Well, that's interesting.
So kind of honestly a little bit of a disappointing result for me because I really want to keep working on this question related to optimizing management, particularly management with prescribed fire to benefit turkey populations and specifically to increase their vital rates. But it also, I think, is very important for people to know and to actually have hard numbers and data to show that fire in and of itself is not a magic cure. Like all the pieces of the ingredients have pieces of the puzzle or all the key ingredients have to be there.
Yeah. No, I think that's important. And you're like you said, you now have another ongoing study. I suspect that some of those treatments, sunlight will not be a limitation.
No, sunlight's not going to be a factor in this one. Yeah.
Yeah, and in the one that I have ongoing, I can tell you from trying to swim through the 3-year return interval compared to the 1 and 2 year interval, that is not a problem with us either. It's pine
Yeah.
savanna, and that's how this works. Unfortunately, it frustrates some people, but we can't do all of it at once. We would love to solve all the problems with one study, but this is what we do is we build on it, and you've done it in this closed canopy context, which I will say a ton of our burning is occurring in that context.
Hmm.
And
It absolutely is.
data suggests that the expected benefits that the fire would confer to nesting success are suppressed by the lack of sunlight availability.
That's right. That's right. Got to have both.
Yeah.
I mean, that's what I always say, the way I teach it, the way I present it at workshops, everything. The sunlight just gives us the ability to grow what turkeys need, and the fire, and the other, alternative management options like fire with herbicide, herbicide, then fire, all that is just managing that potential that we have created by allowing that photosynthetically active radiation that grows plants to hit that understory where the turkeys live.
Hmm. Yeah. Well, that makes a lot of sense. Were there any other things that you think are noteworthy or that
Yeah,
folks
one
can?
other thing that I will throw out because we talked a little bit about this in the context of corvids was that um, we did change our methodology during year one and year two, and specifically during year one. we were trying to add a little bit of realism to this situation before we knew that, or before we really realized how important it was to model nest success during that laying phase, because we know so little about it. We weren't thinking that when we initially designed it, so we actually covered the eggs during year one with a little patch of burlap, like a little from a burlap, like a brown burlap sack. And so we just cut up a bunch of these sacks and we took that burlap out in the woods and we left it out in the woods for several weeks so it would just get weather and get all the scent out of it. So basically just smell like the woods. And we covered all of our nests there in that first year in 2019 with burlap to cut down on that aerial predation rate, because a lot of previous artificial nest studies have, one of the complaints has been, well, they ended up having a really high bird predation rate because the eggs were uncovered, even though, their hen eggs are sometimes uncovered too. They'll cover them a little bit, but not always. But the rate of predation that we saw was so low during that first year that we thought, well, maybe this is a little bit too good of camouflage. So let's see what happens if we uncover them during year two. And the predation rate doubled almost from year one to year two. So there was an effect of that burlap covering. So overall, the rate in 19 was 16%, and the rate in 20 was 35%. So if you average those together, it came out to around 25% for the 2 years of the study. So that was pretty interesting in and of itself.
Yeah. Which makes perfect sense why, when she lays an egg, she would then take time to put leaves over it before she lit.
Yeah,
And also why they might choose a place with good overhead cover, like the Tennessee project showed,
absolutely.
directly over the nest. I mean,
Absolutely.
it makes perfect sense that would have influenced the avian predation in particular.
So
Yeah.
good stuff.
Yeah, not a perfect study by any means, and I'm sure we're gonna hear some criticisms about that. Hopefully, we've addressed some of those adequately.
Yeah.
But good information that I think there's some things to take from it that are important from a management standpoint.
It's
So
frustrating sometimes, but we put a lot of effort in to get these little tidbits here and there that we can start building the puzzle out from.
yeah,
And also a lot of these studies too lend themselves to creating hypotheses that we can test with other experimental designs.
yeah. One, you learn things like you've already adjusted the way that you're doing things to try to improve on some of the limitations of the approach.
Mhm. Yeah.
But catching 10,000 hens and hoping some of them nest and all the different things, like that's a limitation also. That would cost us, you know, uh, about $2 million more than what you spent on this project.
Yeah. That's exactly right. And I'll, just kind of throw out, I guess on a little bit more personal note, like, it's not personal, it's still professional because it was part of the publication process for this paper, is that, I mean, we got a reviewer that essentially said that they would not review this paper because it was an artificial nest study during the first round of reviews. And like we've talked about all the potential drawbacks of this experimental design. We've laid them out there on the
Probably,
table
you're
over
probably
the
open
past
about it.
hour. What's
Yeah.
that?
When you're probably open about it within the publication.
We were open about the limitations within the publication. We cited literature that highlighted the caveats of these types of studies, but let's not throw the baby out with the bathwater, right? Like, just because it has limitations does not mean it's not useful.
That's right. One to doing that suggests that there are other approaches that don't have limitations,
Right.
and that is false.
Right. Yeah,
There are limitations to every approach.
absolutely. No study is perfect and no study is all encompassing, as much as we might wish for it to be.
Track everything
Yeah.
forever.
Yeah.
It would be awesome. I want to get as close to that as possible, but it's not doable.
Yeah.
So, yeah,
Well, cool.
because that's a pretty closed-minded view of it.
Yeah. So that's more of like, I don't know, just kind of something that I wanted to throw out there to the scientific community, that maybe we should, like, I understand that there's caveats associated with this experimental design, but that doesn't mean that it does not still have value to add
Yeah.
to the turkey
One,
management community.
making sure that you openly acknowledge the limitations of the approach is absolutely a criticism that is deserved and needs to be addressed. Not, I don't, it sounds like you did in your paper, but I'm just saying, like, that would be a valid criticism of a reviewer to say, hey, this has limitations and you need to point those out. I
Agreed.
do that in basically every paper I review, and every one that I submit, people do that to me, and that is making us better as scientists. That's in good faith. We're trying to make sure that the limitations are clear to the readers.
Yeah.
But that same thing is, and the bad faith part of that is throwing the baby out with the bathwater. It doesn't mean that because it's a flawed approach that it doesn't have use. If that was the case, we wouldn't be able to use any of the stuff we do.
Well, and here's another thing that I'll add in too, that kind of bigger picture, kind of, zooming out even further, is that in wildlife science, we always are walking this balancing act between realism and experimental control.
That's right.
The more realistic a study is, oftentimes the less control we have, and it becomes much more of a
Yeah.
correlative study than a
And the
study that can
less,
get at causation.
right. And the less we know about what really is causing, like you said, causation, we know the more realistic we get, often the less we actually know what caused the
Right.
observations.
It becomes more correlative, whereas the more experimental control we have, sometimes we have to give up realism for that. I mean, like your pulp facility, you've got tremendous experimental control, but you have had to sacrifice some of the realism of having poults actually out in the wild, because you can't monitor poults in the wild. So you have to do it that way.
Well, and we've
We can't
also,
monitor poults in the wild to the extent and
right.
the intensity that you are.
For example, we weigh the pulse 4 times a day.
Yeah.
We have the best growth rate information that has ever been gotten.
Yeah.
But that's because you cannot do that in the wild.
Right. So you would just, so it's just because it's not realistic, do we just never want to attempt to learn that? I mean, I think that's
To me,
ridiculous.
like we were saying, I know we're going to record an episode on this, and we'll probably bring this up again. Uh, but to me, we've learned such a remarkable amount already from the poll work that I can't imagine someone would think that it wasn't valuable information
Agreed.
because of some of the limitations of it.
Hmm.
We're not. I'm not standing here trying to say it has no limitations, but it has some strengths that are allowing us to do some stuff that you cannot do in wild populations.
Right.
You just can't. You can't do it.
Yeah. Yep. So all research has limitations.
Yes. That does not mean that it isn't useful information that comes from it. You just have to acknowledge it and try to improve it and take different approaches. See, that's really where it comes down. You take different approaches to get at the same question, and the different approaches have complementary strengths and weaknesses,
Hmm.
right? So you start to get a better picture of the whole picture when you start to have that kind of complementary work. And we've already had some looking at real hens nesting in landscapes that are being burned frequently. And,
Yeah.
then you have this kind of study that complements that approach really well by
Yeah.
giving you a lot of control over that.
Yeah. And that, yeah, I think that's a
So,
good overview.
yep.
Anything else you got?
No, I feel like we've beaten that dead horse.
All right.
Maybe we'll probably have like 50 comments about burning during nesting is what's causing the declines. Even though
Well, we can get to that We can get to that later and talk about how the fact that we're burning single-digit percentages of the landscape, whereas turkeys are declining in some areas at a much larger scale. So I don't think that's the primary cause.
burning during nesting is probably 0.1% of the available habitat for turkeys or something in the South.
But if that's happening on the tract of ground that you have access to, then
it might be all of your turkeys.
It may be all of your turkeys. So maybe we'll hit on that one here before too long again.
Maybe if we get some votes on it, we can go to it and take it on directly. I think we have proven we're not going to shy away from topics because people get mad at us about it.
No, we clearly aren't going to do that. But
so, okay. Well, good stuff.
Appreciate y'all.
You know where to find us if you have any questions or thoughts or want to share stuff with us. Thanks for all the support. Hope y'all enjoyed the footage that we cut in on YouTube for those that are, have been asking and appreciating seeing what we're talking about. So, good stuff. Congrats on the publication. See y'all later.
Wild Turkey Science is part of the Natural Resources University podcast network and is made possible by Turkeys for Tomorrow, a grassroots organization dedicated to the wild turkey. To learn more about TFT, check out turkeysfortomorrow.org.